We need to convert this hexadecimal to an octal notation, and to do this we are going to notice all of these F's. Now, in a previous video we've talked about what this 0x means, and it's just basically stating that everything after it is a hexadecimal. So knowing that, we know if we write out 0 through 9, these are all just numbers, but when we write out 10, 11, 12, 13, 14, and 15, well, in hexadecimal, this is an A, B, C, D, E, and lastly F. That should be going there, 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 and now F is 15. So when we write this, we are going to have a 15 here, 15 here, 15 here, and lastly a 15 here. Now, knowing this, we have to write this in the binary form. Well, to find the binary for 15, we're just going to set 15 like this. We know it's less than 2 to the 4th, but it's greater than 2 to the 3rd. So we're going to have 2 to the 3rd, 2 to the 2nd, 2 to the 1st, 2 to the 0. And if you want to know more about how to convert from hexadecimal to binary, there's a video linked below the like button in the playlist. But this is 1, this is 1, this is 1, and this is 1. So the binary conversion of this is 1. And then when we write this in here, we're just going to have a 1, 1, 1, 1 for the first 15. Next 15 we have 1, 1, 1, 1. The next 15 we have 1, 1, 1, 1. And the last 15 we have these 1s. Now, to convert to octal from this, we are going to look at 3 of these at a time. So we look at these 3. We're going to look at these 3. And actually, I'll do it in a separate color so it's easier to see. So we're going to look at the next 3. We're then going to look at the next 3. And then we're going to look at the next 3 here. And we can see that after we look at this next 3, we have a single 1 outside. And if we have a single 1, or if we have 2 1s or whatever, we're going to add 2 zeros to it. And now it has 3 in it. So now, knowing this, we are going to look at all of these columns, and we're just going to divide them out like this. So we're going to write lines in between all of our columns. Now, we're also going to draw a line like this, and each of these 1s, because we're converting to octal, represents 2 to the power of something. So this first one right here is 2 to the power of 0. This next one is 2 to the power of 1. And then this next last one in the front is 2 to the power of 2. So knowing this, we're going to have 2 to the power of 2 right down here, plus 2 to the power of 1, plus 2 to the power of 0, because they're all 1s. However, if they were like 0 here, we would not include this 2 to the 1, it would just be a 0 written out. And so knowing this, when we add all these together, 2 to the 2 is 4, 2 to the 1 is 2, and 2 to the 0 is 1, we get 7. We can see it's the same for this one, this one, this one, and this one. So for these, we are going to write 7, 7, 7, and 7. And this right here would carry over through all of them as well. It would even carry over to this last one that's different. We always do this when we're trying to convert from this hexadecimal to binary to octal. But for this last one, we see that we have a 0, 0, 1. Well, what that means is that we don't have 2 to the power of 2. We don't have 2 to the power of 1. We only have 2 to the power of 0. So that means we are only going to have a 1 here. And this is actually going to be our answer. So this is the conversion from hexadecimal, technically to binary, and then to octal. That is our answer for this problem.